Okay, hello everyone. In this video, we are going to discuss about derivative of Laplace transform and its corresponding numericals. Then we are going to discuss about integration of Laplace transform and its corresponding numericals. This one and this one. In our last class, we have been discussed in detail about numericals based on Laplace transform of integrals, and also we have been discussed numericals based on a Laplace transform of derivatives. In this lecture or video, we are going to discuss first derivative of Laplace transform and its corresponding numericals. So let's start. According to this property, nth derivative of Laplace transform of a function f of t is equal to nth derivative with respect to s. Here Laplace transform of f of t will be written as 0 to infinity e to the power minus st into f of t dt will be equal to nth derivative of this one. This one also can be written as capital F of s will be equal to minus 1 to the power n into Laplace transform of t to the power n into f of t. Okay. So here it is. Here proof starts. Okay, we know that Laplace transform of a function f of t is equal to 0 to infinity e to the power minus st f of t dt, or we can write this one as capital F of s equal to this much. Let this is your equation number 1. Now we are going to differentiate both the side of this equation number 1. Differentiate equation number 1 with respect to s, we get here that implies d by ds of capital F of s equal to, here you can see this is the function of s, this is the function of t will be act as the constant. So if I am going to differentiate this one e to the power st with respect to s, it will be minus t e to the power minus st into f of t dt, because whenever we are going to differentiate this e to the power minus st with respect to s, minus t will be act as constant. So minus t into e to the minus st into f of t dt. Let this is your equation number 2. That implies first derivative of capital F of s with respect to s, or d by ds of capital F of s will be equal to this minus taken outside 0 to infinity e to the power minus st into t into f of t dt. In this fashion we have been written. D by ds of capital F of s will be equal to, here minus can be written as minus 1 to the power n. This much is nothing but Laplace transform of this function. This function is nothing but t into f of t, because in general we know that Laplace transform of a function is nothing but 0 to infinity e to the minus st f of t dt. So here if I am going to consider this one, this integral, here this is the function f of t, entire this one t into f of t. So this integral is nothing but your Laplace transform of this function, that is your t into f of t, right? Now differentiate with equation number 2, this one with respect to s once again. So this left hand side will be d square by d square of capital F of s will be equal to, here this one is going to be derivative with respect to s. That means another minus t is going to be multiplied. So minus t square into e to the power minus st into f of t dt, right? So that implies d square by d square of capital F of s will be equal to, here minus 1 to the power 2 can be taken outside of the integration, minus 1 to the 2, 0 to infinity e to the power minus st, here t square taken nearer to this f of t and considered as whole function, this one. So in this integral is nothing but Laplace transform of t square f of t square f of t. Okay. Hence in general, here you can see the first derivative is nothing but minus 1 to the power n Laplace transform of t f of t. Second derivative, whenever we have been considered, then minus 1 to the 2, and this t power increased 1, that means t square. So second derivative means minus 1 to the power 2 came and t square came. Okay, likewise, in general, if we are going to consider nth derivative of f of s, capital F of s, it will be minus 1 to the n into Laplace transform of t to the n f of into f of t. Okay, so or we can write Laplace transform of t to the n into f of t will be equal to minus 1 to the power n nth derivative of f of s, because we know that minus 1 to the power n is nothing but 1 by minus 1 to the power n. Okay, minus 1 to the power 2, suppose we are going to consider, will be 1 by minus 1 to the power 2 also 1. So here you can see that if I am going to consider this term, Laplace transform of t to the power n f of t will be equal to 1 by minus 1 to the power n, this term. So 1 by minus 1 to the power n is nothing but minus 1 to the power n nth derivative of capital F of s. Okay, so here it is proved. We intend to prove this one. Nth derivative of Laplace transform of a function will be equal to minus 1 to the n Laplace transform of t to the n f of t. Here we proved. Some books has been written in this fashion, that is Laplace transform of t to the n f of t will be equal to minus 1 to the n nth derivative of f of s. Any one of these expression you have to remember. Okay, for the numericals. Now we are going to go for the numericals based upon this property. Okay, first numerical is your this one, that is your find the Laplace transform of t sin at. Here I in bracket written that solve using derivative of Laplace transform. Okay, here as per the question we have to find out the Laplace transform of t sin at. Okay, to solve we use derivative of Laplace transform by this rule, by the rule of your derivative of Laplace transform. We know that Laplace transform of e to the n f of t is nothing but minus 1 to the n nth derivative of f of s, capital F of s, where capital F of s is your Laplace transform of f of t. This one. Okay, this one, right? Now if I am going to compare given question with this rule, it is found that n is what? Here you can see Laplace transform t to the power 1 sin at. Here t to the power n f of t, right? If I am going to compare this with this one, then n is your 1 and f of t is nothing but sin at. And here fs, capital F of s, is nothing but Laplace transform of corresponding f of t. So here f of t is your sin at. So capital F of s, which is your Laplace transform of sin at, we know that a by a square plus a square. So hence Laplace transform of t into sin at will be minus 1 to the power n d by ds of, here n equal to 1 means we are going to consider only first derivative. So minus 1 to the power 1 first derivative of f of s. Here f of s is nothing but a by a square plus a square. A by a square plus a square. So here minus is there. Minus 1 to the power 1 means minus. And d by first derivative of this one with respect to s will be how much? Will be a, will be constant, a by a square plus a square whole square into 2s, okay, because we know that 1 by x derivative is nothing but minus 1 by x square. Okay, so if we have suppose x square, then it will be 1 by x square whole square minus into 2x is the derivative. And here this will be minus of a square plus a square whole square, and derivative with respect to s, this one will be 2s, right? So finally we found the Laplace transform of t sin at minus minus, it will be plus 2as by a square plus a square whole square. This is your answer. This question also you can solve by traditional method. Okay, refer to uh, number number 15. Okay, here you can see in our 15th basic uh, Laplace transform, wherever we have been discussed. See, in our previous class, maybe first class, we have been discussed Laplace transform of some elementary function. In your 15th elementary function, whenever we consider f of t equal to t sin a t, we derived Laplace transform of this function traditionally, and we found same 2as by a square plus a square whole square. So here I have to write refer to number 15th elementary uh, elementary function, right? Elementary function, elementary function, elementary function, whatever we have been discussed previously, right? Now now we are going to go for the another question, that t to the power n e to the power at Laplace transform. By using derivative of Laplace transform, we know that Laplace transform of t to the power n f of t equal to minus 1 to the n nth derivative of capital F of s, where capital F of s is your Laplace transform of f of t. So if I am going to compare with question, then n equal to n, however f of t is your e to the power a t, and f of s will be required. So f of s, capital F of s, is nothing but Laplace transform of your f of t, where f of t in the question is your e to the power t, and we know that Laplace transform of e to the t, e to the at, is nothing but 1 by s minus a. You can refer to our elementary functions. Already we have been discussed that e to the power at, e to the power at Laplace transform. Here e to the power at Laplace transform is your 1 by s minus a. I suggest that you have to remember these uh, last expressions of last expressions of Laplace transform of all the elementary functions, whatever we have been discussed previously, up to 16th elementary functions and corresponding Laplace transforms we have been already discussed. I suggest that you have to remember, it will be required to solve this type of problems, right? Now now we are going to consider, now we are going to find out Laplace transform of this one, t to the power n e to the power at will be equal to minus 1 to the power n nth derivative of f of s, that is your 1 by s minus a, right? Okay, now first we are going to find out first derivative of 1 by s minus a. First derivative of 1 by s minus a is nothing but minus 1 by s minus a square, or it can be written as minus 1 to the power n into 1 factorial by s minus a square. Then second derivative of 1 by s minus a. So here is the, already we found the first derivative, and then second derivative means another derivative of this one. So this one means here you can see uh, minus, this is your minus 1 to the power n, means minus into 1 factorial divided by s minus a square. So derivative with respect to s again means minus is there, again minus of 1 by s minus a square, again square, that means s minus a to the power 4 into derivative of this one, 2 into s minus a. Okay, so here s minus a 1 cancelled out, so it will be 1 into 2 by s minus a whole cube, right? So same thing it has been written. So this one also can be written as 1 into 2 means 2 factorial by s minus a whole cube. Okay, easy differentiation. So we can write here minus is minus sign is cancelled out, but we can write that this one can be write that minus 1 to the power 2 into 2 factorial by s minus a whole cube. So minus 1 to the power 2 factorial by s minus a whole cube. Likewise, nth derivative of s minus a 1 by s minus a will be, here you can see second derivative will be minus 1 to the 2 factorial by s minus a to the power 3. Likewise, nth derivative will be minus 1 to the n factorial by s minus a. Here, second derivative s minus a to the 3. That means 2 plus 1. So, nth derivative will be n plus 1. Okay. Now, Laplace transform of t to the n into e to the at will be how much? This one. Minus 1 to the n. Minus 1 to the n already is there. Minus 1 to the n. And nth derivative of this one, nth derivative of this one, we found this minus 1 to the n factorial by s minus a to the power n plus 1. We have to just substitute. This will be minus 1 to the n factorial by s minus a to the power n plus 1. So here minus 1 to the power n minus 1 to the power n, we can write minus 1 to the power n plus n 2n into n factorial by s minus a to the power n plus 1. That implies Laplace transform of t to the n into e to the at will be equal to n factorial by s minus a to the power n plus 1, because minus 1 to the power 2 to the n minus 1 to the power 2n will be always 1, because minus 1 2n means always it will be even. So minus 1 to the power any even means it will be 1. Okay, so this will be the answer. Next we are going to go for the another numerical which will be based upon this property, that is your derivative of Laplace transform. That is your Laplace, find the Laplace transform of t into e to the power t sine 2t. Okay, so according to derivative of Laplace transform, we know that Laplace transform of t to the power n f of t is nothing but minus 1 to the power n nth derivative of capital F of s, where capital F of s is nothing but Laplace transform of this f of t, right? Now, as per the question, if I am going to compare, then here t to the power how much? T to the power 1. So, here n will be 1 and f of t is nothing but e to the power t sine 2t, this much. E to the power t sine 2t. Okay? Okay. Therefore, capital F of s is nothing but Laplace transform of this one. Okay, Laplace transform of this one. This is nothing but your f of t right now. So Laplace transform of e to the power t into sine at. This can be found by using fast shifting theorem. So here I used the fast shifting theorem. Okay, already we have been discussed previously. So first we have to use the fast shifting theorem to find out the Laplace transform of e to the power t sine 2t. According to fast shifting theorem, we know that Laplace transform of e to the power at f of t is nothing but f of s minus a, right? So here, if I am going to consider only this one, Laplace transform of this, then here f of t is your sine 2t. Laplace transform of sine 2t, already we know that 2 by a square plus a square means a square plus 2 square. This is nothing but called as your f of s, capital F of s for this function, okay. So if I am going to consider Laplace transform of e to the at into f of t, or Laplace transform of e to the at sine 2t, then this is nothing but capital F of s minus a. Here capital F of s is nothing but 2 by a square plus a square. So f of s minus a means instead of a we have to put s minus a, means s minus 2. So 2 by s minus 1, sorry, was s minus 1, because if I am going to compare this one with respect to this one, here a is what? A is 1. So 2 by s minus 1 square plus 2 square, right? So Laplace transform of e to the at into sine 2t, we found 2 by here s minus a whole square is, and 2 square, if I am going to simplify, we can found a square minus 2s plus 5. Okay, now see, don't be confused that here fs we are going to consider this much, and here fs we consider this one. You should not be confused over here that this much portion we considered to find out Laplace transform of e to the ft by using shifting theorem. So for this one, you just consider this one. We do not have any type of numericals here. This one, only this one. If we have, then e to the f of t is nothing but capital F of s, and here f of t is your sine 2t. Laplace transform of sine 2t is your this one. For this one, this 2 by a square plus 2 square will be capital F of s, and e to the 80 sine 2t Laplace transform will be this one. Okay, okay. Now we are going to go for our original question, whatever given in our initially. So Laplace transform of t into e to the power sine 2t. Here we are going to use the derivative of Laplace transform. So according to that, Laplace transform of t into this one is considered as the so-called f of t. Initially we have been considered. Okay, initially we considered f of t is your e to the power t sine 2t. So e to the power sine 2t will be how much? Minus 1 to the power n, because if I be compare this one with this one, then here n is 1. So minus 1 to the power n means 1, and first derivative of the Laplace transform of this function. We found Laplace transform of this function is nothing but this one. So 2 by a square minus 2s plus 5. First derivative we have to find out. That means d by ds of this one. So here minus 1 to the power 1 means minus 1. And if I am going to differentiate this 2 by a square minus 2s plus 5 with respect to s, then it will minus of 1 by 2 is there, 2 over written over here, 1 by this much a square minus 2s plus 5 whole square, and derivative of this one 2s minus 2. Then if I am going to simplify this, here you can found this minus will be plus, and if I will take common 2 from these terms, so it will be 4 into s minus 1 divided by a square minus 2s plus 5 whole square. So this will be the answer, right? Now next question, find the value of 0 to infinity t e to the power minus 30 sin t dt. Okay, suppose this question it has been given. This question can be solved by using derivative of Laplace transform. How it is? Here solution starts. It is given that 0 to infinity t into e to the power minus 30 into sin t dt. Okay, 0 to infinity sin e to the power minus 30 t into sin t into dt we can write. See, if I am going to consider this much, this is nothing but Laplace transform of t sin t for s equal to 3. See, in general we know that, here I have written no. Laplace transform of f of t is nothing but e to the minus st 0 to infinity into f of t dt. Okay, suppose if s will be 2, so 0 to infinity e to the minus 2t into f of t dt will be nothing but Laplace transform of f of t, but for s equal to 2. Same thing it has been written over here. This is nothing but your Laplace transform of t sin t for s equal to 3. Okay. Now we are going to use the derivative of Laplace transform for this function. So Laplace transform of t sin t. Here, if we are going to use derivative Laplace transform in general, then t to the power n f of t will be minus 1 to the power nth derivative of capital F of s. So here if I am going to consider this one, this Laplace transform of t sine t with this one, then n will be 1 and f of t is your sine t, right? So this is nothing but minus 1 to the power n means 1, d by ds means first derivative of Laplace transform of sine t. Okay, here first derivative of f of s, f of is nothing but Laplace transform of corresponding f of t, and here f of t is your sine t. I written like this, Laplace transform of sine t. So minus 1 to the n, and for s equal to 3 you have to write at the subscript also. Okay, so is equal to minus 1 to the power 1 is nothing but minus d by ds of, we know that Laplace transform of sine t is nothing but 1 by a square plus 1, because sine at is nothing but a by a square plus a square. Here a is your 1, so d by ds of 1 by a square plus 1. Now derivative of 1 by a square plus 1 with respect to s is nothing but minus of square of this one, a square plus 1 whole square. Derivative of a square plus 1 is nothing but 2s. So here minus minus will be plus, and it will be 2s by a square plus 1 whole square. But we have to put s equal to 3 here. For s equal to 3, at last we have to put, so if I am going to put for s equal to 3, then it will be 2 into 3 divided by, instead of s it will be 3 square plus 1 whole square. So this will be 2 into 3, 6 by 9 plus 1, 10 square 100. So 6 by 100 is nothing but 3 by 50 is your answer. Okay, so here we have to stop our discussion in this class. In our next class or next video, we are going to discuss the next property of Laplace transform, that is your integration of Laplace transform and its corresponding numericals. Okay, so thank you so much for watching this video. Thank you.